So despite the promise of easier programming, many people were skeptical of Hopper's idea. She once said, "I had a running compiler, nobody would touch it. They carefully told me computers could only do arithmetic, they could not do programs." But the idea was a good one, and soon many efforts were underway to craft new programming languages. Today, there are hundreds. Sadly, there are no surviving examples of A0 code, so we will use C, a modern programming language, as an example. Let's say we want to add two numbers and save the value. Remember, in assembly code, we had to fetch values from memory, deal with registers and other low-level details. But this same program can be written in C like so. Notice how there are no registers or memory locations to deal with. The compiler takes care of this stuff, abstracting away a lot of low-level and unnecessary complexity. The programmer just creates abstractions for needed memory locations, known as variables, and gives them names. So now we can just take our two numbers, store them in variables we give names to. In this case I picked A and B, but those variables could be anything, and then add those together, saving the result in C, another variable I created. It might be that the compiler assigns register A under the hood to store the value in A, but I don't need to know about it. Out of sight, out of mind. It was an important historical milestone, but A0 and its later variants weren't widely used. Fortran, derived from formula translation, was released by IBM a few years later, in 1957, and came to dominate early computer programming. John Backus, the Fortran project director, said, "Much of my work has come from being lazy. I didn't like writing programs, and so I started work on a programming system to make it easier to write programs." On average, programs written in Fortran were 20 times shorter than equivalent handwritten assembly code. Then the Fortran compiler would translate and expand that into native machine code. The community was skeptical that the performance would be as good as handwritten code, but the fact that programmers could write more code more quickly made it an easy choice economically, trading a small increase in computation time for a significant decrease in programmer time. Of course, IBM was in the business of selling computers, and so initially Fortran code could only be compiled and run on IBM computers. And most programming languages and compilers of the 1950s could only run on a single type of computer.